and you'll be amazed at how fast it works. Now, the cool thing though is that cloud-based services can actually take the game a lot further. This is how you're going to do intent recognition. This is how you'll do translation. These services are just too complex to actually run them locally on a phone or a simple device. So that's why you need to have cloud servers to actually do this. So the cool thing also is it's a common API. If you want to do speech recognition on iOS, Android, and Windows, because your game is multi-platform, for example, you're going to have to learn all these SDKs separately, because the speech SDK from Google, for Apple, and for Microsoft is different. So you'll have to learn 3 speech SDKs. If you use a cloud SDK, the cool thing is it's one API. You just make a call, and it's one SDK you have to learn. The quality will be way better. The quality of the voices you will get, the quality of the recognition you will get will be way, way, way better. The other cool thing is you can have more consistency, because you all know how the default text-to-speech voice on iOS is very different than the one on Windows and the one on Android. So now if you have like an experience that uses text-to-speech, suddenly as you play cross-platform, all the voices sound different. And one platform is better than the other, and you know, I mean, do you really like the default voice in Waze? I mean, it's not great, right? And it changes from one platform to another. It's like, you don't want this in your games. And you'll get these extra services. But of course, they cost money. Now, in terms of, can you fit it in your game and your monetization? That's your problem. You gotta fit it. I don't know, it's like anything in life. Any decision you make for your game, see if it fits. What I will tell you is, if you ever design some kind of an experience, and of course a lot of this is used more in like enterprise VR because cost is usually less an issue, but if you have a scenario, consumer or enterprise or something, and you think that these technologies would work great, and you've prototyped it, and it's great, and the users love it, but you just can't work the cost, pay me. Part of the feedback that I bring back to engineering is also sometimes pricing. But I cannot go back to the engineering team and say, this is too expensive. They're going to say, says who and why. And then we have to do a cost analysis. Ping me, let's have a chat. Let's see if I can bring some more feedback. But I need that feedback. Or anything that part of this, if something doesn't work the way it is, and it's important to you, ping me. I love to gather feedback. The best of both worlds is to use both, of course, but then it's more work, more engineering work. So now, as part of cognitive services, we have a whole set of speech services that you saw, and we have one great SDK. I call it basically the one speech SDK to rule them all, because that one speech SDK has support for speech recognition, speech synthesis, translation, intent, custom recognition, and custom voice in one single SDK. And that SDK is available in a crap ton of languages, as you can see, and it's available on a ton of platforms as well. This is the new Microsoft folks, by the way, when you look at this. We're not just a Windows shop. Look at all the languages that are supported. You've got UWP, which is Universal Windows Platform, C#, C++, .NET Core, Java, Python, iOS Objective-C, JavaScript, Node.js, and even REST services, so you can call it from any other language as well. Now, there was one problem, is we didn't have any support for Unity. Because Unity, maybe C#, there were some kind of, incompatibilities. We all know how Unity does sometimes things a little different in their engine. And just because something works in C# doesn't mean it necessarily works in Unity. So there were a few things that were incompatible. And did anybody see this talk that I did in September? Yeah. Just curious. A few of you? Yeah. So the slides are pretty much all the same, as you can see. The demos will be completely different in terms of under the hood. On the surface, they look the same. The implementation, very different. Last September, I demoed how I basically took our REST API and our WebSockets API, and I wrote my own samples to do text-to-speech and speech-to-text and everything. Since then, I've worked with our engineering team. I showed them how Unity works, and I also showed them what was wrong with their implementation that was breaking in Unity, and showed them how to fix it, and lo and behold, they fixed it. And now, our SDK has support for Unity, and it's coming out very soon. I am told this month. So I don't have an SDK to give you now. The samples I will show today, they're not on my GitHub yet because it's still an internal version of the SDK. But as soon as it becomes available, all of that will get released to you. And this way, what you see today, you'll be able to start using it. So let's ditch the slides and focus on this. So the first link is the link to the main cognitive services speech docs. There's no support for Unity in there yet, but there will be soon. The other links are the samples that I designed myself that you could experiment with today in Unity if you want. I will not show those samples today. Today I'm going to show you the new way of doing things, which is with the new SDK. So basically by teaching our engineering team how to fix this problem, I basically destroyed an entire summer of work for myself. Because all that work that I had done now becomes invalidated. It's not necessary anymore. Because we have a real SDK, so there's no need to use my samples. But in the meantime, you can use them, and in a few weeks, hopefully when this ships, you can use the real thing. So what does the real thing do? Let's take a look at it. So, the first one I want to show, actually, you know what? Before I show this one, let me open a different project. Where is my Unity? Unity text-to-speech, that's the one. Oh, I did not update this. Okay, it's fun. Let's do a live update in front of the audience. So, it's going to tell me it doesn't match, yes. Well, there's like a new version of Unity like every day or something, you know. They actually created a tool to simplify the upgrade because they know how bad it is, you know. I mean, it's supported, so that's good. Yes?
So you mentioned pricing. Is there like separate education pricing for schools and colleges?
So the question about pricing is there a special pricing for like schools and things like that? Per API, no. We have some academic grants that you can apply to. So if you search like Azure for education and things like that, you might be able to find some things. There's some requirements there. But then it gives you like lump sums of credits you can use, and then you can use them for whatever service, including this one here. So, by the way, these services also, they all have a free tier, by the way. So you can actually play with this today without having to spend a dime. You can do sometimes like the equivalent of something like 5,000 hits per month for free completely against APIs. But just as a developer, you can just go nuts and have fun and experiment. And most of the time, I'm actually using the free tier as well, because even though I work for Microsoft, I still have an internal account. And every month, they send us a report of who spends the most money on Azure. And trust me, you do not want to be at the top of that list. So, all right, so this demo here, this one actually is one of my original demos that I showed before, because even though the SDK includes all the speech recognition services, there's still no text-to-speech in the SDK itself. This one you still have to use the REST API. So if you want to do text-to-speech, you still get to use this demo right here, and this one is on GitHub. Right now, you can use it. So what I've done here is basically, I'm not going to dive deep in the code. You can go explore it. And actually, just who actually writes code here for a living? So it's maybe 60% of the room. So I know a lot of people would just glaze over if I started showing too much code. There will be a little bit more later, but I'm just going to show you how it works. So there's the speech manager is the main class that contains everything that you need to be able to do the speech interactions. The text-to-speech client is basically the code that specifies all the commands for the actual text-to-speech. Secret helper is just something for myself because I don't want to put my Azure keys in GitHub, so it pulls them from environment variables, but you would actually go put in the actual things. You don't need that. So let me just run this so you can see it. And with this one, I can actually type anything. So let me make sure my sound is on. All right, so welcome. Oh, see, I can't type. Welcome to Unity Developer Day in New York City. And then you can pick different voices for this here.
Welcome to Unity Developer Day in New York City.
So it's actually a pretty good voice. It's probably one of our best ones. This is based on our neural text-to-speech technology. And when I clicked the button, it sent the text to the server, and then it's downloaded the audio back and it played it. So that was pretty fast. Of course, if you are in like shoddy kind of like internet areas or whatever, then your mileage will vary. You can actually play with the pitch a little bit because the way that you're sending data over is with a protocol called SSML. It's the Speech Synthesis Markup Language. It's an open standard from the W3C. So it's not something we invented, we follow the standard. And it basically lets you change different things in sentences to change like the pitch. You could even go change, for example, pitch or speed like in the middle of the sentence if you want. In this case here, when I change the pitch, it changes it for the whole sentence. So I can go, for example, from -10.
Welcome to Unity Developer Day in New York City.
Gloomier. And then chirpy, peppy, you know.
Welcome to Unity Developer Day in New York City.
And then you can switch to different voices and even languages as well. So for example, you can even go with different accents as well. So like British, everything sounds better with a British accent, right?
Welcome to Unity Developer Day in New York City.
Very suave. And then if you want to have fun, like for example, if you've ever heard a French Canadian speak English, I'm allowed to make fun of them, I'm one of them. You can pass an English string to a French voice.
Welcome to Unity Developer Day in New York City.
So if you've ever had calls with people at Ubisoft or something like that. All right. So you can basically play with multiple, and this is not the full list of languages, by the way. It's just I populated the list by hand in my code, and I got tired of typing everything. But there's like a long list, and we basically have something like 30, actually no, I think it's 40 something different text-to-speech languages that we support. And some of them will have male, female, some of them will have just one voice, so you can easily play with this. So this is for the text-to-speech integration. Now let's switch gears to speech recognition and intent recognition. So this demo is not on my GitHub yet. It will be. Let me first start with speech recognition. So this one, as you can see in here, let me just zoom in so you can see a little better. Editor. I have like a plugin right here. So I've got different plugins for x86, Android, and for Windows Store, which is used for like Xbox, HoloLens, and things like that. So these are DLLs that come in, so everything will come as a package. You will just import as a custom package in Unity, and everything will be good to go. And then I've got like, the code is actually not too bad. You know, for example, if I look at speech recognition, so the speech recognition code is just this for the demo. It's not that much, it's very reasonable. And this is pretty much to implement like the, everything that happens and it displays on screen and all. So I'm gonna show you right now is pretty much how it works. So this one actually uses continuous recognition. Once I start it, it basically just keeps recognizing it, and it automatically does silence detection as well. So that whenever it's done with a sentence, it will just display it, and then I can keep on talking, and I don't have to click it. So let me start the demo. Okay, so now, as you can see, I can basically just start talking, and then while I'm talking, it's actually showing me on screen like the words that are coming back from the server. So you don't even have to wait for the full sentence to be uploaded and downloaded. You get interim results as well. What do you think? Good? Yes. I mean, it's pretty good, right? This is detecting the whole thing. I can actually, if I want, even enable translation. So I've even gone like further. Instead of just doing translation into one language, you can actually specify multiple languages. So I have a drop down here with multiple languages here, and I can say enable translation. And now everything that I say will not only be recognized, but it will also give me a live translation in multiple languages. I love it when people say, wow. It means the demo is working. You can even use different alphabets, like let's go Arabic, Japanese, and Chinese Mandarin. And while it's translating everything, I have absolutely no way to know if the translation is good. But I've tested it with my international coworkers who have validated multiple languages for me, including Russian, And I can check French myself, of course. Pretty cool, huh? So this is basically, so this is a speech recognition. The beauty is that it's actually quite simple to use, just to show you very quickly in the code. And of course, our samples will show you how to use it. You're able to start dropping this into your code very easily. But let me make it a little bigger, like this. So if I look at this here, when I start